example 2 once again, but this time around we are going to use method 2. So in place of L, I'll substitute that L with the P so that we differentiate between method 1 and method 2. Right, so we still have the same question. It's only that we have P in place of L. So a loan of P is repaid in the manner 2,000 after 2 years, 1,500 after 1 year, P over 2 3 years later, and of course a final amount of 3,000 another 4 years later. So compound interest is 18% per annum monthly for the first 5 years and 19% per annum annually for the last 5 years. So calculate P, the initial amount of the loan. Right, so we see that from this information that we're given, we have the value of the loan being P at the time 0. But now that loan is going to accumulate some interest after 2 years. So we would need to know what the value of that loan is in the first 2 years before the payment is made, or when the payment is made, because in so doing we are able to see the balance of the loan. Right, so we see that after 2 years the payment is made of 2,000. Then after the 2 years there is another payment that was made on the 3rd year, and that is 1,500. So we see as well that in the 5th year there was a rate change, or change of interest rate, and also how it is compounded. So in the first 5 years we know that the interest rate was 18% and compounded monthly, so implying that our I, which is the number of periods in a year, is 12. But beyond 5 years we have a different interest rate of 0.19 expressed as a decimal, and that being compounded annually. Then in the 6th year we have a payment of P over 2 that was made. Then so it implies that basically that each and every time a payment is made, we would need to see what the balance of the loan is. Then we subtract with the payment at that particular time up until we get to the final period, which is 10 years. And in the final period, an additional amount of 3,000 was made, which cleared the balance of the loan. So now this is a different method. It's different from the one that we looked at in method 1. Right, so the balance of the loan after 2 years, we would need to get what the value of the loan is in 2 years. So we have P at time 0. So with the loan that it accrues in the 2nd year, we are going to multiply that by 1 plus 0.18 divided by 12 raised to the power 2 times 12, because we've got 2 years and we've got 12 periods within a year. Then we are going to subtract the value that was made, because it is actually reducing the value of the loan. Therefore, simplifying further, we are going to have P times 1.015 raised to the power 24 minus the 2,000. So with that, we can see that that would be the value of the loan, or rather the balance of the loan after 2 years. Now in the 3rd year, we can also calculate the value, or rather the balance of the loan after 3 years, because we are saying that from the balance that was left in the first 2 years, which accumulated interest for 1 more year, when the 2nd payment was made of 1,500, we are going to subtract that from the balance that was left in the previous year. Right, so that's why we have a 1.015 times 1 times 12. That is for 1 year. So it means that the balance that was left in year 2 has accumulated some interest. And now at that particular time, that is the time we reduce the balance of the loan. So we subtract 1,500 from the balance of the loan. Right, so we see that in the 5th year, things change. The rate of change changes. So we need to calculate what the balance of the loan is up until the end of the 5th year, because beyond that, we would be using a different interest rate. So from year 3 to the end of year 5, that is equivalent to 2 years. Then we are considering the balance that was there for the loan in the 3rd year, which is that chunk that we have over there inside the first set of parentheses or brackets, ending with minus 1,500. Then we multiply that one by the interest that it acquires or accrues, that is accrued, of 1.015 raised to the power 2 times 12, because we have 2 years and the interest was compounded monthly, and that happens for 2 years. So that is the balance at the end of 5 years of that particular loan. Right. So now that we have the balance of that loan after 5 years, perhaps before we move on, we can expand the brackets so that we have maybe something that is reasonable and pleasant to look at. So when we expand the parentheses or brackets into each and every term, we see that 1.015 is going to multiply with the minus 1,500 raised to the power 24. We have the same multiplying the 2,000 times 1.015 raised to the power 12. Now with the laws of indices, that would give us to the power 36. And the same would go for the first part. P times 1.015 would end up being to the power 60, because we add the powers, remember, from the laws of indices. And I encourage you to check our video on laws of indices if you have no idea of what we are doing here, because that will be beneficial. So when we are multiplying the sum terms, we just add the powers. That is what we learned from indices. Right, so beyond the 5 years, we have the rate or the interest rate being 0.19 as a decimal per annum and compounded annually. So if that is the case, then we see that in the 6th year, to be precise, a payment was made of P over 2. So now that payment is being made on a balance that we obtained in the previous step times the 1 plus 0.19, because from the end of the 5th year to the 6th year, the balance that is left is the one that we obtained from the previous step times the interest that is accrued for 1 year, that is given by 1 plus 0.19. And then because there was a payment that was made of P over 2, we subtract that so that we get a new balance. So now when we subtract that, we are going to get the final balance being something that is given in that way, because we're saying that after the 6th year, we are going to find what interest is accrued at the end of the 10th year. So that is 4 years later. That is to say that whatever we had in the previous step in the 6th year, we are going to multiply that by 1.19 raised to the power 4, because it's 4 years up until that balance accrues some interest. And at the end of that 10 years, the last payment is made of 3,000. So that's why we are subtracting the 3,000. And take note, the 1.19 raised to the power 4 only affects what was in the previous step, because that is what accrued interest, or the balance that we got from the previous step. Then we subtract the 3,000 so that we equate that to 0. The logic is this: if we had made sufficient payments, that would reduce the balance to 0, or totally clear the balance of the loan. So that is what we are using. That is the rationale. So now that we have this huge equation, we are going now to simplify further so that we get to where we want to get to. So I know perhaps it might be an issue for some to know how to go about this. The easy approach would be to divide throughout. But before we divide, let's move the 3,000 because it's negative to the right hand side so that it becomes positive. As it is positive, we divide now by 1.19 raised to the power 4. So that would clear the 1.19 raised to the power 4 of the interest that is accrued in the last 4 years. Now with that, we can actually now focus on the parts that are remaining on the left hand side. So it is advisable that we try to keep our answers as exact as possible, but there are instances and times where we cannot keep them as exact as possible, like in the case of the P. So the first P, we would just compute whatever we have here using calculators, of course. That would make our lives easier, but trying to keep our values to 4 significant figures or even 4 decimal places if it's possible, so that we at least don't exaggerate on the accuracy of our solution or overdo it. So now if we do that, we are going to get a 2.907p for the first P. And for the second term, where we have a minus 2,000, multiplying with that, we are going to get all these other terms. So it is also a good thing to group like terms. So I shift the minus 0.5p closer to the 2.907p so that we are able to deal with the p, and all the other terms are just kept by themselves and they're negative because they were subtracting. So with that, then we shift all these other terms that are not multiplied by a p to the right hand side because we are now solving for the p. So if we do so, we are going to get $8,115.42 on one side, and on the p side, which is the left hand side, we are going to get 2,407p. But of course, this is not the final answer because we have to find what p is. So dividing throughout by 2,000, rather 2.407, that's not 1,000, but that's 2.407. We are going to get a p-value of 3,371 as our final answer. So that's how we would solve our question. And remember to subscribe so that you don't miss out on any of our future uploads. Make sure to check out all the other playlists we have so far. They might be beneficial to you, especially if you are a mathematics, statistics, financial mathematics student. And of course, I'll leave you with the following task. Find a question and post it on the related topic. Remember once again, your questions, feedback are always welcome here. Subscribe, like, and share so that you don't miss out on any of our future uploads. Thank you for watching Numbers Simplified. Remember, God loves you.